Hello friends, in this session we will talk about graphs. We will focus on four areas. First we will look at the basic graphs, then we will talk about the movement of graphs, area under graphs, and finally we will look at questions involving maximization and minimization of values. Let's look at the first, let's first look at a couple of basic graphs. Y equals to x, y equals to x square, now once we have the graph of y equals to x square, the graph of any even power of x that can be derived from this. We'll come back to this in a little while. Y equals to x cube, while we are looking at the graphs of y equals to x square and x cube, it is worthwhile to intersect them with y equals to x. This will be the graph of y equals to x. This point at which it is intersecting, x equals to 1, x equals to 1, y is equal to 0. I'm sorry, it will be 1 comma 1. So x equals to 1 from here, and x equals to 0 over here. Between 0 and 1, x square would be less than x. Similarly, if I look at y equals to x cube, y equals to x cube will be something like this. Once again, this point is 1, this point is minus 1. So this will be the graph of y equals to x cube. Now if I was to draw the graph of, let's say, x to the power 4, x to the power 4 will follow the same structure as a graph of y equals to x square, just that the degree of steepness will be higher. So let's say this will be the graph of y equals to x to the power 4. Obviously it is a little too sharper increase, but you get the point. As the value of x will increase, the pace at which the value will increase, that will also go higher. So therefore the graph will be more steep. Between 0 and 1, the value would be lower. Beyond 1, the value would be higher. Same thing replicated on the RHS. Also, if you recall, for even functions, it is symmetric about y-axis. So all the even powers, they are symmetric about the y-axis. If I look at the graph of x to the power 5, x to the power 5 will be more extreme as compared to the graph of x cube. So it will follow the same structure as the graph of x cube. And also all odd functions, it will be symmetric about origin. So that's the graph of y equals to x cube and all the odd powers of x. Next one, the graph of y equals to 1 upon x. 1 upon x, this is an asymptote about the center. So this is the graph of y is equal to 1 upon x. So xy equals to a constant. Next up, the graph of y equals to mod of x. So y is equal to mod of x. Next one, the graph of y equals to e to the power x. So y is equal to e to the power x. I would like to also draw the graph of y equals to log of x in the same thing. So this will be the graph of y equals to log of x. So this is y equals to log of x. Next, sin x, cos x, tan x. The graph of sin x, it would be something like this, from 0 to pi. So 0, this is pi, this is 2 pi. At pi by 2 it will be maximum. So this is sin of x. Cos of x was the opposite of this. It starts from 0, comes to 0, and then goes back again. So this is cos of x. So this is 0, this is pi by 2, this is 2 pi, this is 3 pi by 2, and this is 2 pi. Next up, y equals to tan of x. It starts from 0, it goes all the way till infinity. Again starts from 0, it goes all the way till infinity. So this is the graph of y equals to tan of x. I think for our basic understanding, a couple of more graphs we would like to discuss over here, and then we will be done with this. Next up, the graph of a quadratic function. For a quadratic function, the graph would be either like this or it will be like this, depending upon in this expression ax square plus bx plus c, whether if a is greater than 0, then it will be like this. If a is less than 0, then it will be like this. Whether it intersects or not, that depends on the value of the discriminant. If d is greater than or equal to 0, then it will intersect. If d is less than 0, then it will not intersect. So that's the graph of quadratic functions. In general, for an equation y is equal to a x to the power n plus b x to the power n minus 1 dot dot dot, it should have n roots. Because it should have n roots, it will have n points of intersection. However, please note that this is the maximum possible number of points of intersection. It may so happen that the roots are coinciding with each other. In case the roots coincide with each other, then you will not get as many roots. Or alternately, it can also happen that the roots are complex, they are imaginary. In case the roots are imaginary, then once again you will not get as many roots. But this will give you the maximum number of roots that this expression may have. Next, we talk about the movement of graphs. If we are looking at the movement of graphs, so we could be looking at f of x plus minus k, and we could be looking at f of x plus minus k. As far as the graph of f of x plus minus k is concerned, what we'll have to do is, let's say if the graph of, just take a simple example, y is equal to mod of x. So y is equal to mod of x, this is the graph. Now in this, if I do a plus 3 minus 3, so y is equal to mod of x plus 3, y is equal to mod of x minus 3. If I do a plus 3 in this, it will simply move by 3 points in the vertical direction. So this will be the line of 3. Similarly, if I do f of x minus 3, this will move down by 3 points. So this will be the line of minus 3. So if I am doing a f of x plus minus k, you really don't have to do anything. You just move the graph by that many points up and down. Similarly, if I am looking at f of x plus minus k, in this case the movement will be the slightly different. Let's say if I am looking for y is equal to mod of x plus 3, and I am looking for y is equal to mod of x minus 3. For y equals to mod of x plus 3, let us ask ourselves at what point will it touch 0. When x plus 3 is equal to 0, if x plus 3 equals to 0, that means that x is equal to minus 3. If x equals to minus 3, that means that the graph of this expression, it will be like this. So this will intersect when x is equal to minus 3. Similarly, if I look at mod of x minus 3, this will be touching 0 when x minus 3 is equal to 0, which means that x equals to plus 3. So if it touches when x equals to plus 3, this becomes the plus 3. So to summarize this whole thing, what you need to remember is, if I have f of x plus k minus k, then it will move by that many points up and down. Similarly, if I have got f of x plus minus k, then it will move horizontally by that many points in the opposite direction. So for x plus k, it will be negative, moving in the negative direction. For x minus k, it will be moving in the positive direction. So just remember this, you would be comfortably sorted with as far as drawing the graphs is concerned. In order to further consolidate your understanding of how to draw graphs, let's look at the graphs for the following functions. So there are 5 graphs that I would like you to draw. So take some time and draw these graphs. Having said this, let's get started. First things first, what is the graph of log of x? Log of x is like this. Once we have the log of x, the first one, log of mod of x. If I have the log of mod of x, this means that for even for negative values of x, because y will become the mod of x will be positive, that means that the graph will be defined. So even for negative values of x, we would be able to replicate the graph. So this will become something like this. So this will be the graph of log to the base of e mod of x. Second one, log to the base e of x, taking a mod of that. If I take a mod of log to the base e of x, this is log to the base e of x. If I take the mod, the negative portion will become positive. So this negative portion will go up, this will disappear. So this will be the graph of log to the base e of x mod of this. Third one, log to the base of e mod of x whole of mod. If I take the mod of log to the base e of x mod, let us first focus on this part. As we just saw in the first part, the graph of this function is like this. Once we have the graph of log to the base e mod of x, next we take the mod of this. If we take the mod of this, the negative portion will become positive, so this goes up. Similarly here also this becomes positive, this also goes up. So this is the graph of log to the base e of mod of x whole mod. Next one, log to the base e of minus x. Log is defined only for positive numbers. However, if I define log to the base e of minus x, that means that when x is positive, minus x is negative. When x is negative, minus x is positive. So this will be defined for negative values of x. So this will be the graph of log to the base e of minus x. And finally, minus log to the base e of x. If this is the graph of log to the base e of x, if I do a minus, this will become inverse of this. So this will become like this. So this will be the graph of log to the base e of minus of log to the base e of x. Next one, let's take a look at questions involving the calculation of area between graphs. Here is a simple question for us. Find the area between x square plus y square is greater than 2 and mod of x plus mod of y is less than or equal to 5. In order to draw the graph of the first one, x square plus y square is greater than 2, it would be worthwhile to understand the general form of a circle. The general form of a circle is x minus a whole square plus y minus b whole square is equal to r square, where a comma b is the center of the circle. When we say that x square plus y square, this means that the center is at the origin. So this is the general form of a circle with center at the origin. RHS is r square, so r square equals to 2. That means that the radius of this circle will be equal to root 2. If this is known, then we can say that the first part, the graph of x square plus y square is greater than 2, this will be something like this, where this distance is equal to root 2. Because I am looking for greater than 2, that means that I am looking for area that is outside the circle. So that is one sorted. Second part, mod of x plus mod of y is less than or equal to 5. This is again a very important part. The general form of the graph of mod of x plus mod of y is less than or equal to something is like this. This is the graph of mod of x plus mod of y is equal to k. If this is equal to k, this distance will be equal to k. So for example, if x equals to 0, mod of y is equal to 5. If mod of y is equal to 5, that means that y is equal to plus 5 minus 5. Similarly for x, if y equals to 0, mod of x equals to 5, so x equals to plus 5 and minus 5. So this becomes the general graph for mod of x plus mod of y is less than or equal to k. Digressing a little, if from here I was to draw the graph of mod of x minus 1 plus mod of y plus 3 is equal to 7, how will we draw this? In order to draw the graph of mod of x minus 1 plus mod of y plus 3 equals to 7, what I will have to do is, if it was at the origin, it would have been 7 units. This would have been the graph. Now if I do a x minus 1, x minus 1 means that this needs to move 1 unit horizontally to the right. So from here, moving for x, this will become 1 unit horizontally, it will have moved to the right. So that becomes mod of x minus 1 plus mod of y is equal to 7. The second part, mod of y plus 3. If it is y plus 3, that means that it needs to move down by 3 units. So from here, it will move down by 3 units. The graph will be something like this. If you ask me what is the area of this mod of x minus 1 plus mod of y plus 3 equals to 7, the area of this will be same as the area of mod of x plus mod of y is equal to 7, for which this is 7, this is 7, 7 7 is 49 upon 2 multiplied by 4 such blocks, 49 upon 2 into 4, 98 is your answer. However, coming back to this, here we have got mod of x plus mod of y is less than or equal to 5, so this becomes the graph. Now we have been asked to find this area because it is less than this one, greater than this one. So we have to find the area of this region which is outside the circle and inside the rhombus. So to find the area, let us first calculate the area of this rhombus. For this rhombus in this triangle, this side is 5, this side is 5. So 5 5 is 25. There are 4 such triangles. So the total area will be 25 into 4, 100. This 100 also includes this circle. For the circle, the area will be pi r square. R is equal to root 2. So this will become root 2 square for 2 pi. So overall 2 pi. My answer 100 minus 2 pi. That's your. Next, let's take an example. Find the area of the region bound by mod of x minus a plus mod of y minus b is equal to 5. Where let us say a and b are positive integers. So a and b are positive integers. Now what will be the value of this area? Like I was explaining some time back, if I look at the graph of mod of x plus mod of y is equal to 5, it will be like this. Now when you put a modulus inside this or inside this, it does not change the graph per se. It only changes the location of this graph. So if I do a x minus a, this will move to the right by a units. Similarly, if I do a y minus b, it will move upwards by b units. The basic diagram will remain the same, and if the basic diagram remains the same, the area will also remain the same. So therefore, in order to calculate the area, I really don't have to worry too much about a and b. This is nothing but mod of x plus mod of y is equal to 5. And if mod of x plus mod of y is equal to 5, that means that this is 5, this is 5, 5 5 is 25 into 2, 50, 50 straightforward is your answer. Next up, let us say we have to calculate the area included by any of f of x equals to mod of x, g of x equals to mod of x plus 2, mod of x equals to 2 with the x axis. This is x axis. First one, f of x equals to mod of x, f of x equals to mod of x. Second, g of x equals to mod of x plus 2. So this will be same as mod of x moved to the left hand side by 2 units. So this one is f of x, this is g of x. Third one, mod of x is equal to 2. If mod of x equals to 2, that means that x equals to plus minus 2. So this is minus 2. X equals to plus 2 will be over here. So mod of x, x equals to 2 with the x axis. So this becomes the base. Now we have to look for the area that is closed. As far as the closed area goes, this is one portion, and from here to here this is the second portion. So the overall area that we have to calculate will be this one. Now once we know the basic things are in place, calculating this area should not be difficult. This can be done quite easily. Let's just start from here. If this is the line of x equals to 2 and this is the graph of mod of x plus 2, that means that this point will be 4. So the height here becomes 4. this overall length, this is 0, this is plus 2, this is minus 2, so the overall length will be equal to 4. Over here, because this is x equals to 2, this is also x equals to 2, so this height will be equal to 2. Now if I look at this triangle, in this triangle this angle is 45, so this angle will be 90 degree, because this is 45, this is also 45, so half of this will be 45, this will also be 45, so this becomes 90. And if this is equal to 90, this length is equal to 2, that means that this side will be root 2, this side will also be equal to root 2. And once we have this, the total area, this can be found as 2 into 2, 4 upon 2, plus area of this triangle 4 into 4, 16 upon 2, 8, minus the area of this triangle, which will be equal to half of root 2 into root 2, so which is equal to 1. So this is equal to 2 plus 8, 10, 10 minus 1, 9 units. So 9 units will be the area that is required for us. Next we take a look at another variety of problems which is best handled using graphs. Let's say f of x is equal to maximum of 2x plus 1 comma 3 minus 4x. We have to find the minimum value of f of x. In order to find the minimum value of f of x, let us first see what will be the graphs of these two functions. First one, I am looking at, let's say 2x plus 1. This is y equals to x. If x becomes twice, this is y equals to 2x. Plus 1 would mean that this will move upwards by 1 point. So from here, this is the graph of y equals to 2x. This point will be 1. This point will be minus 1 by 2. Next one, y equals to 3 minus 4x. For 3 minus 4x, let us first say we will have y equals to x. Y equals to x would be like this. Y equals to minus x will be like this. Y equals to minus x multiplied by 4 will be like this. Y equals to minus x and plus 3 will go upwards by 3 points. So the graph will be like this. So this is 3 minus 4x. This is 2x plus 1. Because it is maximum of the two graphs, that means that as long as this value is higher, we will take this, and after the intersection, this becomes lower, this becomes higher, so we will take this. So this will be finally the graph of max of 2x plus 1 comma 3 minus 4x. The question is, what is the minimum value of f of x? Very clearly, the minimum value will happen when these two are intersecting. When will they intersect? They will intersect at 2x plus 1 is equal to 3 minus 4x. 4 plus 2, 6x is equal to 2, x is equal to 1 upon 3. So x equals to 1 upon 3. At x equals to 1 upon 3, f of x will be equal to 2 upon 3 plus 1, so which is equal to 5 upon 3. 5 upon 3 is your answer. What you need to understand here is that this question could actually have been answered even if we did not draw the graph here. We had to draw the graph to confirm one thing, that the function should not have more than 1 points of intersection at which the value could be a minimum, number 1. Number 2, in case a range has been specified in the problem, then you will need to see whether the values, the point of inflection, it is coming within the range or it is outside the range. So let us say here, if I had specified one more condition, x is contained in 3 to 7. If I had specified that x is contained in 3 to 7, then the maximum value would have been very easily answered from the graph. We would have known that this point of intersection, it is happening at x equals to 1 by 3. So therefore, beyond this point, it is only 2x plus 1. And because it is 2x plus 1, the value will continuously keep increasing. If the value continuously keeps increasing, the answer would have been 7 into 2, 14, 14 plus 1, 15. The minimum value, it would have happened at exactly 3. So at 3, it would have been 3 to the 6 plus 1, 7. Likewise, we would have been able to tell the answer. In general, what you can do is, whenever a question like this is given, just equate the two of them whatever point the value of x you get, that will give you your answer. However, if you really want to be safe, it is a good idea to first draw the graph and confirm whether it is a case of maximum or minimum, and whether the minimum or maximum value, it will lie within the range that has been given or it will be outside the range. So with that, you should be sorted as far as calculating the minimum and the maximum values of functions are concerned.